Okay, lowering powers formulas, or reducing. As I look at this piece right here, reducing powers, this is the section I'm looking at. So we already did the half angle formulas one, haven't we? We've already done cofunction identities. We've done double angles. We've done almost it all now. I mean, sum to product, product sum, that's tomorrow. That's easy. Today is like the pinnacle of your confusion, okay? So it'd be normal if today you were like, this is the most confused I've ever been in my math class. And then generally it gets easier after this, okay? You could take sine squared and rewrite it as 1 minus the cosine of 2x over 2. Why is this useful? It's generally useful in calculus. I cannot find the antiderivative of sine squared very well, but I can find the antiderivative of 1 minus cosine of 2x over 2. So it may not make sense to you what that means right now, but I'm just saying that that's a big reason why we do this. Okay? So cosine squared of x is equal to 1 plus cosine of 2x over 2. And tangent squared of x is equal to 1 minus cosine of 2x over 1 plus cosine of 2x. How are all the formulas similar? They all have cosine, so that's nice. They have that in common. That is shared among them, which is good news. All right. You see that the pluses and the minuses make them a little bit different. What you're going to be asked to do is to take these expressions and reduce them to the first power of cosine. So that's why they're called power reducing. They go from a squared down to the first power. Now we do end up with a double angle in the process, but that's all right. We end up being able to work through that. So rewrite the following in first power of cosine. Sine squared we write as 1 minus cosine of 2x over 2. And cosine squared we write as 1 plus cosine 2x over 2. Go. A negative on the inside? Yeah. So if you put a negative x, then this would become a negative 2x. No. No. Suppose time a negative goes away. Does that answer your question? Got it. Okay. We multiply. 1 times 1. 1. 1 times cosine of 2x. Cosine 2x. Negative cosine 2x times 1. Negative cosine 2x. And cosine 2x negative times cosine 2x. This is confusing for people, but it's negative cosine squared of 2x. You don't change anything with the angle. You don't get like 4x squared or something like that. Okay. So you just leave the double angle alone. You just square the operation. All right. All over what? 4. What do you notice? Cosine 2x is canceled. They cancel, giving me 1 minus the cosine squared of 2x all over 4. Am I done? The whole goal is to write it as cosine to the first power. So I must make another substitution to get rid of this cosine squared. The only difference is we know what cosine squared of x the substitution is, but we don't know cosine squared of 2x, so we got to make a new formula. So look at what happens. Sine squared of x, we end up with a cosine of 2x. What happened to the angle? It got doubled. So this will end up with a cosine of 4x. So sine squared of 2x is 1 minus the cosine of 4x over 2. This one, cosine squared of cosine squared of 2x is 1 what? Plus cosine of 4x, the angle doubles, over 2. Don't worry about 10, it'll never come up. So we get 1 minus, instead of cosine squared of 2x, I write 1 plus cosine of 4x over 2 all over 4. Okay, I'm going to take the number 1 and I'm going to rewrite it as 2 over 2. So I end up with 2 minus 1, which is 1, and I distribute my negative minus cosine of 4x all over 2. My common denominator here is 2. Then over 4 over 1. Now I can multiply by the, I get 1 minus the cosine of 4x all over 8. You may write the answer like that. That's fine as well. Some people write it as 1 over 8 times 1 minus the cosine of 4x. I don't care. You do what you want. You just choose what you want, okay? Just realize the book chooses their own deal. What? There's a 1 in front of this cosine, so 1 over 8 and then 1 over 8 cosine. Okay, we try another one. Sine to the 4th. Uh-oh, this was to the 4th power. What do I do now? Yes, Kyle's got it. We break it up in sine squared times sine squared, which would be 1 minus the cosine of 2x over 2 times 1 minus the cosine of 2x all over 2. So we multiply this out. 1 times 1. Then I get 1 times negative cosine of 2x, and then negative cosine of 2x times 1. That will give me negative 2 cosine of 2x. Then I have negative cosine of 2x times negative cosine of 2x, positive cosine squared of 2x over 4. I have to insert something for this cosine squared of 2x. Cosine squared of 2x, I saw in last problem, I inserted 1 plus the cosine of 4x over 2, all over 4. Question? I have to find common denominators. What's my common denominator? 2. So I will have 2 over 2 or 2 minus, instead 2 cosine of 3, 4 cosine plus 1 plus cosine of 4x all over 2 all over 4 over 1. What can I combine in the numerator? 2 and 1 make 3. 4 cosine of 2x plus cosine of 4x all over 2 over 4 over 8. Couple things I want you to know, okay? Please watch this. Cosine of 2x plus cosine of 4x does not equal the cosine of 6x. No way. Another thing I want you to, you can't combine these. All you can do is just leave them alone. You can't simplify that. Here's another one. Cosine of 2x times the cosine of 4x. That's just simplified. You can't write that any different. You're done. Okay? There's actually a power, or there's actually a sum to product and product to sum formula we learn tomorrow, but we're just going to leave that alone. Okay? So if you come across this, leave it alone. After that, I think that's pretty much it. So if you come up with this in your assignment today, don't do something crazy here. Don't write this as cosine squared of 8x squared or something like that. That's not what it is, okay? Yeah. This one to here. Here to here. So 2 over 2. 2 over 2. 4 over 2. 4 over 2. So I'm finding common denominators with this 2. So I rewrote this as 2 over 2. Wrote this as minus 4 cosine of 2x. Yep. Was that the same question? Oh, let's just ask it next time. Okay, so here's your assignment, okay? I can't give you specific numbers necessarily because one of them is an example problem. There's only so many of these problems I'm going to have you try, so let me explain this. 2 of these problems are from page 557 in your book, okay? I want you first to do sine squared times cosine squared. We already did that one, didn't we? I want you to do it again, okay, for a homework problem, and you can just check it against the example that you have in your notes. Second of all, cosine to the fourth. We already did sine to the fourth, so cosine to the fourth shouldn't be that difficult. That's the same as number 10 in your book. Cosine to the fourth times sine squared. That's going to be new and a little bit more difficult. That's like number 12 in your book. Cosine squared times cosine squared times sine squared. Or you can use your answer from here and just multiply it. And then this is extra credit. If you want to do sine to the 6 times cosine to the 6 and bring that to class, you know, the day of the test, and it's correct, I'll give you extra credit for it. Okie doke. There you go.